Thank you. Right. Okay, so hi everybody, my name's Alan from Dawn Robotics, and I'm going to try and give a high-level overview about how you might go about building a robot with your Raspberry Pi. So, introduction. Yes, so basically trying to convey that robots are cool and fun and why you'd want to build one with a Raspberry Pi. About me, as I say, my name's Alan Broom. I founded this company, Dawn Robotics. Basically, I'm coming to the end of a PhD, and Dawn Robotics is my way of trying not to get a proper job and to kind of keep doing robots and stuff. The overview of the talk, as I say, I'm going to go through the basic pieces, things you might need to think about when building a mobile robot, a robot you can drive around, or it can drive around on its own using a Raspberry Pi. And I'm going to start the talk, because I've learned doing talks with robots before that you should show the robot at the start, because otherwise people get bored. So this is a robot that I've built with the Raspberry Pi, and if you go to our website and have a look on our blog, we've got instructions for building this. Could, in theory, I think, control it from this computer, but I don't want to muck that up. So once this is powered on, essentially what we've got with this robot is it's a nice simple chassis with electric motors. It's all driven by 6 AA batteries. We've got a little extra motor driver board which will actually control the motor, and that all connects up to the Raspberry Pi, which then connects to a Raspberry Pi camera, and it's got a Wi-Fi dongle on it. And it's running a web server, so any web-connected device, I don't know if you can see it at the back, but essentially you can connect to the web server and then see the images coming back from the camera, so you should just be able to see Mike come in. And then follow him around, or it's a little bit tough to drive. So, I mean, technically this is only a remote control toy at the moment, so you'd want to put sensors on it and make it autonomous and get it to drive around on its own. But it's the kind of the basic thing you can do. As I say, all the source code for that is online, so if you wanted to take that and adapt it to your own robot, you can. But I'll get on with the talk now, so I don't run out of time. Now, when we talk about robots, there's lots of different types of robots that you could build, and that's one of the exciting things about building robots. So you've got humanoids, you've got the Asimo robot from the Honda company up at the top. Mobile robots, which are what I'm going to talk about today. So for mobile robots, I'm assuming something with wheels that can drive around, or maybe you could give it legs, like a hexapod. There's UAVs, which are basically the unmanned aerial vehicles, these drones, planes which fly themselves. Robot arms, I love robot arms. This is one from Maplin. It's not particularly great, but it's very cheap and it's good for the price. And then biomimetic robots, which I think is a really interesting area of robotics, where you basically look at the way animals work or humans work, things in the natural world, and that it's a huge mine of inspiration for robotic mechanisms where you can build robots, because obviously nature does it very well, and so it's good to try and learn from nature. So the things you'll need to think about if you're building a mobile robot, I mean, you could break it down in a lot of ways, but the basic things are you need a chassis, some kind of body to put everything on, motors and wheels, some power for it, a motor driver, some central controller or CPU to be the brains of the device, and for that obviously we're going to use the Raspberry Pi, and then some sensors so it can learn about the world, and some software to control it all. So that's what we're going to do in this talk, is go through each of those areas pretty quickly and kind of give an overview of them. So the chassis is kind of going to be the core of your robot. You need to put some thought into that to kind of think how big you want your robot to be, what you're going to put on your robot. So you need to have space for all the sensors and the motors and the Pi as well, and the battery. Everything else needs to be supported by this. And so you've got a couple of options for how you get this. You can either buy one off the shelf. You can build your own out of cardboard or plastic, laser cut acrylic maybe. Or one thing that I think is quite interesting is you can adapt them from existing toys. There are quite a lot of robot toys or remote controlled cars out there which, if you can get them second hand, provide quite a cheap source of motors. And so this is a toy called the Big Track, which I think was actually a programmable robot toy to begin with. So it's quite interesting to think you could maybe take out the innards of that and then give it more intelligence with a Raspberry Pi. So the motors, gearboxes and wheels, these are what makes the robot move. We're mainly thinking about electric robots, or I am in this talk. You could go for petrol-powered motors and stuff like that, depends how kind of ambitious you were. But the three main electric motor types that you probably look at are DC brushed, DC brushless and stepper motors. So DC brushed are probably the simplest to use. You can essentially, they'll have two terminals on them mostly, and you just attach them up to your battery and they'll go in one direction. If you switch the connection over, they'll go in the other direction. Brushless motors are, I think they use those on remote control cars more. They can be more efficient but a little bit harder to control. And then you've got stepper motors, where if you need to make lots of very precise movements, to kind of move them around a certain number of angles, and stepper motors can be good for that. When you're actually buying your DC brushed motors, the things you want to be looking at, you can usually find a data sheet for them, is what voltage they need to run, what kind of current they'll be drawing from the batteries, and also the torque, the kind of the turning force they have. So the stall torque is the kind of the turning force that they will be exerting when they're kind of held and stopped. So really you want to be, I mean, mostly you will just buy whichever motors, put them on your robot, and if the robot moves, then you think, well, that's enough. But you can, if you want to, put a little bit more calculation into it and think, well, my robot is going to weigh so much, and therefore I'll need this much torque to move it. So that's the kind of the calculations you can look at. And then if you've got a gearbox on your motor, this can take a high speed motor and kind of get it down to lower resolutions but higher torque, and that will all depend on the gear ratio of the gearbox. Moving on, we've got power. So again, we're looking at electric batteries really for most robots. But as I say, there's quite a few options. So, you could try petrol and motors. Hydrogen fuel cells as well. I think there are educational kits which can drive objects with a hydrogen fuel cell. So, although I doubt they provide enough power to run a Pi. With electric batteries, you've got a lot of different options. You've got lead-acid batteries, which I think they use on the big behemoth robot out there from Pyborg. Alkaline batteries, kind of standard 1.5 volt batteries you buy. They will give you enough voltage to run your motors, but you may find that they can't provide enough current if they kind of have to kind of put in a lot of effort. And so that's why I've tended to use rechargeable batteries in a lot of my designs. And then there's also lithium ion or lithium polymer. These tend to be higher power, a lot lighter weight than the other battery types. But you do have to be a bit careful with these because there's a possibility of fire. Now this is kind of very rare, and I don't speak from a position of expertise on this. Usually with lithium batteries, you need some kind of electronics to control them, to just make sure that they remain safe. And so your mobile phones and laptops will have this all in by default. But if you're building your own robots, you kind of need to make sure that you have everything safe yourself, and that you trust where you've got your kind of control electronics from. Also, when you're charging lithium polymer batteries, you should always charge them within a kind of a lithium polymer charging bag. In the lab where I work, this has now become, we've had a series of kind of safety standards kind of written up about these, because we have actually had a couple of lithium polymer fires, which do look quite impressive when they happen, but a little bit unnerving. One thing to think about when you've got your power supply, actually, is maybe having a separate power supply for your motors and for your logic board. There are quite a few reasons for this, but one of the main ones is that your motors can draw quite a lot of current, and that can cause the voltage to dip that's running the Raspberry Pi, which can cause it to brown out and kind of stop working. So in a lot of designs you'll see they'll have batteries for the motors and then a separate battery for the Raspberry Pi, maybe a USB power bank. So the motor driver is the chip that's actually going to drive your motors, that's going to make them turn. And you can't connect a motor directly to a Raspberry Pi because a Raspberry Pi doesn't provide enough current out from its GPIO pins to actually make the smaller, kind of very small servo motors you can run from a Raspberry Pi, but anything bigger you'll need a separate motor driver board. And there are a huge number of options for this. So just so I'm not kind of basically trying to sell my own stuff, there's products from various kind of companies up here. So the simplest thing is probably the chip on the top left. For those of you who haven't seen it, it's called an L293D. And these you can get very cheaply, about £2 or £3. And there's lots of tutorials about how you would wire that up to your Pi to drive some motors. I would actually recommend, if you can afford it, to go for the kind of the green board above the L293D. That's a newer motor driver called the TB6612FNG, I think it's by Toshiba. But essentially the technical reason is that the L293D will use older bipolar junction transistors, and the other one will use MOSFET transistors, and so you'll actually lose a bit of voltage over the L293D. It'll be kind of wasting more of your electricity. Now the other boards going around, there's the PyroCon from Fortronics, which makes use of an L293D. There's the Pyborg sell a number of motor drivers of different sizes that you can use with your robot, so you should have a chat with them about which ones would be suitable. And there's the new Ryan Tech board as well. But the one that we sell is the one that's in the middle. It's a mini driver board, and that's got a motor driver, and it's also Arduino compatible, but I'll talk about Arduino stuff later on. So that's up to, you've got your chassis, power and motors so far, and now you need basically something to control it all, and this is where the Pi would come in. So your controller, your CPU, it basically serves the purpose of high-level robot control and AI, but also controlling the motors and actually reading from sensors. Now the Pi can do both of these because it's got the GPIO pins that you can connect hardware up to. But a couple of things to bear in mind with the Pi is it doesn't have an analog to digital converter on it. So if you've got any sensors like temperature sensors which need to read analog values, then you'll need an extra chip apart from the Pi to control that, to read that. And a lot of sensors will run at 5 volts, which you can't connect directly to your Pi because that runs at 3.3 volts. So you would need to do some level shifting. You can buy level shifter chips which will basically convert from 3.3 volts to 5 volts. If you don't do that, then you can damage your Pi, so it's just something to bear in mind. So one thing that I'd like to kind of suggest as something to think about is to actually make use of a microcontroller of some sort when you're doing your robotic projects. So some of you might have heard of an Arduino. So kind of, yeah, a lot of you have heard of the Arduino, and that's a kind of a very easy to use microcontroller board. And I would say that it's got some advantages of actually using the two devices together. It's not really an either or, should I use an Arduino for a robot or should I use a Pi for a robot? It's more that the Pi obviously has a lot more computing power than an Arduino, but an Arduino is really designed for interfacing to hardware. So the idea would be that if you have some kind of Arduino or a microcontroller in your project, then that can act as a standalone unit that looks after your hardware and will keep running whilst your Pi does something else. It can't be preempted by other processes, so if your Pi is doing a lot of computationally heavy stuff, there's not a chance that your motor control is going to get starved of resources and not get to run. You also get much more direct access to I/O on a microcontroller. So on an Arduino, you can just tell it, make this pin go high, make this pin go low. Now you can do that on a Pi. You can control the GPIO pins, but especially when you're doing stuff like PWM or interrupts and you're doing it in Python, there's quite a lot of layers between you and the hardware. And also the Arduino will have the microcontroller will have things like an analog to digital converter. It will have hardware PWM, and so it can really kind of provide support to the project.
Did you say what PWM is?
Oh, sorry. PWM is pulse width modulation, and that I probably should have talked about with the motor drivers actually. So PWM. Essentially, it's a signal that goes high and low repeatedly, and the pulse is when you're going high, and it's depending on the width of your pulse. That depends how fast your motors are going to go. So if you have a very long high pulse, from your Raspberry Pi, you'll be constantly sending a signal that goes high and low, and if the pulse when it's high is very long, then in general your motors will be going quickly. That's a kind of a signal to say go fast. And then if it's kind of very short or goes down to no pulse whatsoever, then that means slow motors or stop. Yeah. And so you can generate those signals with a Raspberry Pi, but it's a lot easier to do it, in my opinion, on an Arduino. But it's kind of, with all of these things, it's whichever one you're happier with, really. There's kind of no right answer in any of these things. The other thing is interrupts is when you're getting signals coming in from the outside world and you want your program to respond to them. You can do that with the Arduino and with the Raspberry Pi. Okay, hello. 5 minutes. Okay, so I can go quicker. So sensors are the other things you should be thinking about. These are, so I spoke at the start, a lot of the time I think with robotics, you might have something that you can drive around remotely, but I think the ideal thing, or the thing that we really want to be trying to do with robots is make them autonomous in some way, to kind of get in some level of intelligence so they can do things on their own. And sensors are kind of the way to do this. Sensors are the way that robots will learn about the world. And there's lots of different options you've got to put on your robot, depending on what you want to do. So ultrasonic sensors can measure distance to things. Infrared can measure heat. Maybe you want a robot that could detect fires. And in the same way, you've got gas sensors. You could send a robot into a dangerous building to see if it was safe for humans to go into.
All of those analog devices or digital?
It depends on the device. The ultrasonic is digital. Yeah. Cameras, so that'll come into the Pi. Infrared, I believe, is usually an analog device, and I think the gas ones as well are usually analog, depending on the kind of concentration, although I'm not too certain about that. Yes, it kind of varies between the sensors, really. I'll skip over this because we haven't got much time. Because I wanted to talk about software briefly. So with a robot, there's basically lots of software to write, and you actually have more software really to write with a Raspberry Pi. So you've got low-level control software to write, where you need to read from your sensors and then control your motors and actuators. Actuators, are things like the pan tilt head I've got on my. There are other motors that your robot has that doesn't necessarily make it kind of move forward. So the pan tilt, it can make the robot's head look left and right. You then may have mid-level behaviours, where you want the robot to drive in a straight line or to follow a wall, and that would involve reading from sensors and then sending out different commands to the motors. And then you can think with the Pi, you get the option of having high-level software. You've got computer vision or artificial intelligence, or you could maybe build a map of a building. And the good thing is that there are lots of different libraries out there, such as OpenCV is a good computer vision library, or there's lots of AI software out there, or map building software that you can use as part of your robot, so you don't, because obviously we've all got limited time for these things. And then there's the question of where you actually put your software. So other robots that people might have built before they had the power of the Raspberry Pi, everything would have been on board a little microcontroller board, such as the Arduino. With the Pi, you can put quite a lot of software on the Pi, but then you also have the connectivity of Wi-Fi, so that you can actually send images or sensor data off the Pi and have it on another PC. And that can then control a Pi and make it a Raspberry Pi robot and make it drive around. Alternatively, you could think about actually building a swarm of robots, so having multiple robots with Raspberry Pis on them, and then getting them to communicate together and to cooperate with each other. And so, I'm not sure whether that would have been much use to people in terms of concrete things, more in terms of things they need to think about when they're writing software for a robot. But hopefully you'll have seen that there's quite a lot of different software components you need to think about. And so when you're writing your own robot software, you can end up redoing a lot of work that other people have already done. And so when you are building robot software, it'd be good to think about reusable software and kind of using other people's software to get yourself started, so that you're not redoing everything. And this is where working with the Raspberry Pi and in the Linux environment comes in really handy, because there's lots of open source software out there for people to use. And I'd encourage you, if you do come up with your own software, to kind of release it open source so that people can use it. One thing I'd be interested in talking with anybody, if they've got any ideas after this session, is obviously we've put together the software for the Raspberry Pi robot that we've made, and that's all open source, people can use it. But I'd be interested in asking whether people have any thoughts about whether there could be some kind of general purpose Raspberry Pi robot software, how people are planning to use it, because I would imagine that there's going to be lots of people who have software on a Raspberry Pi robot, but then maybe want to control it from scratch or from another computer. And it would be good if we could build maybe one bit of software that did a lot of that to get people started. And so if anyone's interested in kind of maybe collaborating on that project, I'd be really interested in talking to you later on. And then also higher level up, there's a robot framework called ROS, which stands for Robot Operating System, which is a very nice open source platform. It's probably more for research level or industrial level robotics, but it's something that people have got working with the Pi, and so that can be very useful as a kind of a resource to kind of get you started quickly. And just before I finish, another robot, so start with a robot and finish with a robot. This is a robot called the PiBot, which has been developed by my friend Harry Gee, who's over in the corner. And this is a robot that's designed for education and getting people started hacking around with robots. So if you're, go up and have a chat with Harry at the end, because I think he's got, have you got one to show?
I've got half of one.
Half of one to show, so that's good. So you can have a chat, have a look at that, and it comes in a beautiful, beautiful box. And so, conclusions. Sorry this has been a bit rushed. What I hope I've conveyed is that robot building is fun. There's a lot of different things to think about. and lots to learn whilst doing it. So whilst having a robot that drives around on the floor may not be the most useful thing, there are lots of skills that will be learned and lots of stuff that you can do on the way whilst you're getting there. And there are many, many different ways to build a robot, and that's why it's, I think, a very fun hobby to get involved with, because you can really personalise your robot and make it unique to you and put your own kind of features and ideas into it. So, yes, that's about it. Thank you. Any kind of questions? No?
Could you use like a sensor? You could like a couple of sound sensors as well, and then, for example, the robot will go to the sound.
Yes. No. That would be a really nice kind of simple example to kind of build into a robot. Because then, yes, you could. I mean, there are speech recognition libraries out there for Linux or for Raspberry. So you could try and get fancy and have the robot recognise your voice, or you could just listen to a microphone and try to work out when there's a loud noise to turn towards it. I think if you were going to have, if any kind of direction, you would need 2 microphones so that you could do some kind of direction sensing. But yeah, that would definitely be possible, and it'd be cool if you could say, "Hey robot, come here," and it just comes, or maybe it runs away from the loud noise. So you kind of chase it away. Yeah, fantastic. Yeah. So I try and put it on. Yeah, it's something that sounds very cool to try. The trouble with robotics is there's all these cool ideas. You kind of think, must try that next. Limited time.
How long could it take to build a simple one?
Well, so I mean that it depends really. So I mean, the robot that we've put together there, and we've got instructions for on our site. If you had all the parts, then putting it together would probably not take more than a day, really. And then all the software can be downloaded onto an SD card, so you can go straight away. So that's probably if you've got a kit. If you're doing it from scratch, then obviously it's going to take a little bit longer, and there's going to be researching which parts to do. But I would say that over the course of about 4 or 5 weekends, you could start from scratch and not having much knowledge, and then kind of go to having a robot that can drive around quite simply, I would say. Because there's lots of resources and tutorials on the internet, and our blog we're trying to build into a resource for people interested in getting started with programming and robotics. So.
If you want to get a robot to turn a certain angle using DC motors, is there a problem? I mean, do you really need feedback, or can you do it?
Yeah, so that was the slide that I kind of missed out, which was. Yeah, so if you just put the same voltage on 2 different DC motors, then they're very unlikely to turn at the same speed. And so, yes, usually, this robot that we've got here does have a big problem driving in a straight line. And so, usually you would put encoders, and encoders are basically sensors which tell you how quickly a wheel is turning. And then you would use that as feedback to say, well, the right wheel is turning more quickly than the left one, so therefore I will slow the right motor down a bit, and therefore I'll get them to drive in a straight line. And if you're doing a kind of a precision turn, then encoders, you can get away a little bit. If you've got good motors and you kind of set things up carefully, tune things carefully, then you probably can get away with just timing to do some turns. But if you want accuracy, then encoders are needed. Alternatively, you could use stepper motors. So I don't know if anyone remembers the old turtle robots. I believe that they use stepper motors in them, because stepper motors, you don't just give them a voltage to run, you send them a pulse which says turn a little bit to the left or to the right. And so you send them a specific number of pulses, and they'll have turned a specific distance around. Although then with all of these things you don't have a problem maybe with tyre slip if you're running on certain surfaces, so it's a bit of a problem.
You could
You could use a compass, yes, add an extra sensor. So that's the thing with robots, more sensors is better. You can, yeah, kind of GPS if you're outside maybe, or yeah. So it's a large part of robotics research is getting robots to know where they are and to move accurately within the environment.